burden over and then spacing are friends in the drilling and blast session. And so usually if I want to describe burden, I use something like this keyword, adeswa. Okay, so something that worries you and you must handle or take away from you. So let's assume this images. So every blasting, if we want to do blasting, there is a term you have to be familiar with, which I know most of you might have heard. There's something called free phase. Free phase, okay? If you've heard it before, free phase. What is a free phase? If we understand free phase, then we can take these things one after the other and get it clear. Okay, so free phase is that when I want to blast, assuming it is surface mines, who has ever had the experience of digging a hole? Okay, when you dig a hole, you get sand out. If you are putting the sand back into the hole, what usually happens? You dig a hole, you have sand, gravels, and other things out of that hole. Now you want to close or fill the space back. What usually happens is that when you are filling it back, there's always that excess. Meanwhile, the ground was flat, but after you have finished with that whole activity, you form a heap because there have been something called a swelling. The materials swell, and then you have more of it, which can no longer fit into the hole you dug. And in the same way, if we want to do blasting in the mining industry, the materials always swell. And so assuming I drill within the space like that and I want to blast, we have to create a space for the material to, because it's going to swell, we have to create a space for it so that it can swell freely. And that direction I want the material to throw itself and have that freedom is what we call the free phase. So if I am drilling, or if I drill and I create my blast holes just like this. So if I create my blast holes like how I have done it, if I blast, this hole here has the burden, the trouble of breaking the wall. So assuming this portion is the free phase, this hole here has the burden of moving or blasting this section of the device forward. And so this material in front of this hole, because I have defined that this is my free phase, this section is my free phase. If I want to blast, this becomes the burden of this hole. If I turn it this way too, and I want to blast, you see, if this is my free phase, it means that this hole here has the burden of breaking this material here. This one will have the burden of breaking this material in the middle. This man here will also have the burden of breaking this space. Do you see how they are? So depending on your free phase, any rock material that is in front of a blast hole, which the material has to break forward, is what we term as the free phase, the burden of that material. Then if I have this blast hole here, and assuming I create, they are in line, and then there's this blast hole here, there's another one on its side, then that is what we call spacing. But this blast hole has to blast the material and push it forward this way. This becomes the burden of this blast hole. So from now, if you go into the pit and you see them doing this blasting or drilling, whatnot, and they begin to do the charging, ask the engineer there, where is your free phase? If he shows you your free phase and you stand and look at the blast holes there, once you know your free phase, any hole that is supposed to break in the direction of the free phase, the material in front of it is the burden of that hole. Then if there's this hole on your left and that on your right, the distance or the space between the rock material that is creating the space between the hole on your left and the one on your right is the spacing of those blast holes. Then the ones between the holes in front of them in the direction of your free face is what we call the bedding. So if you remember, we talked about overbedding, and I told you that take away the over. So burden is kind of that load. But this time around, because we call it overburden, because the material you want is sitting, and this one is over it. So we are describing that the material we want is sitting on top of it. That's why it is overburden. But this time around, it is not over it, but there's nothing material, no material sitting on top of the blast hole. So we can use over burden, and so we take the over away and we call it burden. We are done. So let's look at this term, boulder. What is a boulder? What is a boulder at all? What is a boulder? So a boulder is any rock that is beyond, okay, the limits per our fragmentation. You know, we do the drilling we create two things. The drill pattern you see on the surface, the pattern you see, how the drill holes are drilled there on the ground is what we call the drill pattern. It can be in square pattern or staggered pattern or whatever. So if I drill, I expect that the materials break and form a certain size that our crusher can take. So if I drill and then the sizes of the rock that is broken, some of them exceed what our crusher can handle, or even our excavator to pick and put inside the dump truck, we call that particular rock a boulder, because it is bigger and beyond the limits of our machines we have there. Then if I have a boulder explained, after I have blasted the material, the blasted material in the pit there, which we are yet to carry, we call it a muck pile. And if the excavator is sitting on it to excavate those material and put in a dump truck, we say the excavator is mucking. The material it is sitting on to fetch is a muck pile. If it is excavating them, we say it is mucking. Then we have overbreak. So when we have a drill pattern, if the drill and blast engineers are working on a bench and they set out their drill pattern, you know our pit has walls, which we have the footwall, hanging wall, and whatnot. So if you are to blast this space, assuming this space where my camera is, the black section, and you do your blasting and it goes beyond the black section, you have done overbreak. So assuming you are close to the wall and that overbreak happens, you are likely to collapse the whole wall of the pit. And if you're a blast engineer and you mess up like that, they have to sack you. You are not serious, because you have to do your calculations very well and be able to tell that this is how much, this is the energy that will come out of the blast I'm going to do. And because that thing, if you mess up like that, your likelihood of killing people in the pit is high. And so overbreak is not allowed, and underbreak is also not allowed. So we want the optimal. You should always be within the middle and not go beyond. Then we have a chute. If we are underground and we blast our materials, we pass our ore materials through a certain channel we create. Sometimes it is a race. Sometimes we intentionally create a race underground, which no human being is supposed to pass, and we call it an ore pass. And then we will put something like a funnel there that will help us put our ore there and be collecting them onto our small trucks down there and bring to the surface, or into our skip and bring them to the surface. That kind of access is what we call what? A chute. It's a draw point, a draw point utilizing gravity. So I put the ore and then it settles, it throws itself down and collected at the next floor, which is the same as what? A loading point. So draw point and shoot are similar. They use the same, they all do the same, they use the same principles. It's an access point where we throw ore and people or trucks are able to get access to them in the next level. And that's what we call a draw point. So I think we are done.